Now, I want to show you how you can show your thought process with inequalities. Solving inequalities is similar to solving equations. There's a little bit of a difference if we have a negative in front of the variable. So I'm actually going to show you guys two problems for this one without the negative, one with a fraction, how it looks like the equation, and then I'm going to show you how it's different when you have a negative. So the two problems that I'm going to show you are part of your homework. So those of you who actually decided to watch this video get a little bonus. So those are the two problems I'm going to show you. First, let's look at number 29. Whenever you're solving for an inequality, in your homework I want you to rewrite the problem anytime you solve it. So even though I wrote it up here, I'm going to rewrite it down here so that I can really have a clear space to work. I don't have to worry about running into this, and I can see everything. It's only this inequality here. Some people say it's a waste of paper. Like I said in my last video, it is not. Paper was made for education and for learning and for reading, so we are actually using this paper for its original purpose. When you're solving an inequality, the process looks very similar to solving equations. We add the 7 to both sides, and then we're going to multiply by the reciprocal of 3/2 to make 1, and then we multiply numerators, that's 18, divide by the denominator, that's 6. So we have the inequality x is less than 6. Now, like I said with equations, we want the variable on the left side so that we can read this properly. We want to read it as variable sign number. Finally, with inequalities, one of the differences is that we need to actually also show the solution on a number line. Now, you don't have to make a bunch of tick marks. For this problem, that would be enough of what you could draw on your number line with the numbers. Finally, we want to decide how to write our coordinate dot, or our point. Do we want to have this number included in this inequality? In this case, no. This number 6, this coordinate 6, is not included, and so we have it as an open dot. Now notice, I'm writing the arrow, or the graph, above the number line. If I draw it on the number line, it kind of gets lost, and sometimes it's hard to tell where your arrow is going, so I'm going to draw it above. Now we have x is less than 6, we have not included, and we want to show that x is all numbers that are less than 6. All right, now let's look at number 27. Now, first step, subtract 5 on both sides, draw your line. Negative 2x is less than or greater than or equal to 22. Now, when I divide by this negative, this sign actually gets flipped, and I'll tell you a little bit why. I'm going to explain it more in class. But the short answer is we need to find the solutions for x that make this statement true. All values for x that makes this statement true. It works out that if we did not flip the sign, none of the values of x that we found would make the statement true. But if we do flip the sign, then these values do work. So let's just see what I mean. If you pick any number that is less than or equal to negative 11, let's take, for example, I don't know, let's make it easy. Let's say, let's say negative 12. Substitute it in, it should make the statement true. Let's see what happens. So we have, imagine, we have negative 2 times negative 12, positive 24, plus 5 is 29. 29 is greater than 27, so it works for this sentence. Let's see what it looks like for graphing. Drawing the number line, draw your 0 for orientation, and then negative 11. Now in this particular one, we have a negative 11, the number, the coordinate included. So we want to make a solid dot. Once again, we want it above the line so we can easily see the solution. And then we're going to draw our arrow, so that includes all numbers less than negative 11.